Every day, oil refineries produce the fuels that power millions of vehicles, aircraft, ships, and industries around the world. But hidden inside almost every refinery is a massive industrial system that few people ever see. It isn't the distillation towers, the storage tanks, or the miles of pipelines. It's a dedicated hydrogen factory. This hidden facility continuously produces enormous quantities of hydrogen, quietly feeding the refinery's most important processing units. Without it, modern refineries simply could not operate. Yet this hidden hydrogen factory also represents one of the refinery's largest sources of carbon emissions. Understanding this invisible system is the first step toward understanding how one of the world's largest industries could dramatically reduce its carbon footprint. Hydrogen is not an optional part of refining, it's essential. As environmental regulations have tightened over the years, fuels have become cleaner, containing far less sulfur and fewer harmful pollutants than in the past. Achieving that transformation requires vast amounts of hydrogen. It upgrades crude oil into higher-value fuels, removes contaminants, improves fuel quality, and allows refineries to process heavier and more challenging crude oils. Every day, thousands of kilograms of hydrogen move through pipelines across the refinery, quietly supporting almost every major refining process. While consumers see only the finished fuels, hydrogen remains the invisible ingredient that makes modern refining possible. The hydrogen journey begins inside its dedicated production plant. From there, a network of pipelines distributes hydrogen throughout the refinery like arteries carrying lifeblood through a living organism. These glowing pipelines feed hydrogen into hydrotreaters, hydrocrackers, and other critical process units that operate continuously around the clock. Every valve, compressor, and reactor depends on this uninterrupted supply. If the hydrogen network were suddenly interrupted, large sections of the refinery would quickly shut down. This hidden distribution system is one of the most important, yet least visible pieces of refinery infrastructure. Inside the hydrogen plant lies an intricate collection of reactors, compressors, heat exchangers, purification systems, and storage vessels working together with remarkable precision. Every component has a specific role in producing hydrogen with the purity required for refinery operations. Temperatures reach hundreds of degrees Celsius, while gases move continuously through stainless steel piping. Sensors monitor pressures, temperatures, and flow rates every second. Although this facility occupies only a portion of the refinery, it functions as one of its most critical engineering systems, quietly enabling fuel production every hour of every day. At the center of today's hydrogen production process is the steam methane reformer. This enormous industrial furnace has become the workhorse of hydrogen production across the refining industry. Inside rows of catalyst-filled tubes heated to extremely high temperatures, natural gas reacts with steam to produce hydrogen-rich synthesis gas. This process has supplied refineries with reliable hydrogen for decades because it is efficient, proven, and capable of operating continuously at massive industrial scales. Around the world, hundreds of these reformers operate every day, producing the hydrogen that keeps refineries running. But they also reveal one of the industry's greatest decarbonization challenges. Many people assume refinery emissions come primarily from burning fuels. In reality, one of the largest sources of carbon dioxide is often the hydrogen production process itself. Producing hydrogen from natural gas releases significant amounts of CO2 during the chemical reactions inside the reformer, while additional emissions come from burning fuel to maintain the extremely high operating temperatures required. Every kilogram of hydrogen produced through conventional steam methane reforming carries a carbon footprint. This means that even as hydrogen helps produce cleaner fuels, the way hydrogen itself is made creates an important environmental challenge. This creates an engineering paradox. Hydrogen enables cleaner gasoline, cleaner diesel, cleaner jet fuel, and lower sulfur emissions for vehicles worldwide. Yet producing that hydrogen generates substantial carbon emissions at the refinery. The hidden hydrogen factory therefore becomes both part of the solution and part of the problem. As governments and industries commit to reducing greenhouse gas emissions, this hidden carbon source has become impossible to ignore. Decarbonizing refineries increasingly depends on finding new ways to produce the hydrogen they cannot live without. If hydrogen production creates emissions, why not simply eliminate hydrogen altogether? The answer is straightforward. Without hydrogen, modern refining would no longer function as we know it. Hydrotreating would fail to remove sulfur from fuels. Hydrocrackers could no longer convert heavy crude into valuable transportation fuels. Product quality would decline, fuel production would decrease, and environmental standards could no longer be met. Hydrogen is not an optional technology that can simply be switched off. Instead, the challenge facing engineers is much more ambitious. Rather than eliminating hydrogen, they must completely transform how it is produced. The first step is often blue hydrogen. Carbon capture systems remove much of the carbon dioxide generated during hydrogen production before it reaches the atmosphere. Existing hydrogen plants continue operating while their emissions are significantly reduced. Blue hydrogen provides a practical transition that allows refineries to lower emissions without replacing every piece of infrastructure overnight. The long-term vision goes much further. Engineers are replacing conventional hydrogen plants with electrolyzer facilities powered by electricity instead of natural gas. The refinery still receives the hydrogen it requires, but the production process changes completely. One of the refinery's largest carbon sources begins to disappear. This is the green hydrogen factory. Water enters one side, electricity powers the process, and clean hydrogen leaves the other. When supplied by renewable electricity, hydrogen can be produced with little or no direct carbon emissions. The hidden factory becomes one of the cleanest industrial systems inside the refinery. Electrolyzers replace reformers as the heart of hydrogen production. Rather than breaking apart natural gas, they split water into hydrogen and oxygen. Modular designs allow capacity to grow as refinery demand increases, while eliminating the need for fossil fuel reforming. Renewable electricity transforms hydrogen production. Wind farms, solar parks, hydroelectric stations, and other clean power sources feed electricity directly into electrolyzers. The refinery becomes connected to the wider renewable energy system, allowing hydrogen production to become progressively cleaner over time. Unlike electricity, hydrogen can be stored for later use. Large storage systems balance renewable power generation with refinery demand, ensuring a continuous hydrogen supply regardless of changing weather or electricity production. Storage becomes one of the most important assets in maintaining reliable refinery operation. Green hydrogen now flows through the same refinery network that once carried gray hydrogen. Hydrotreaters, hydrocrackers, and upgrading units continue operating as before, but their hydrogen now carries a dramatically lower carbon footprint. Existing infrastructure gains a cleaner future without changing its essential purpose. Most refineries will evolve gradually. Engineers retrofit process units, install new hydrogen pipelines, upgrade control systems, and integrate electrolyzers while maintaining continuous fuel production. Rather than rebuilding entire refineries, industries modernize them one system at a time. The refinery becomes a connected hydrogen ecosystem. Electrolyzers, storage facilities, compressors, pipelines, purification systems, and processing units all communicate through one integrated network, continuously balancing production and demand across the entire site. Artificial intelligence monitors millions of operating parameters every day. AI predicts hydrogen demand, optimizes electrolyzer output, balances renewable electricity, schedules maintenance, detects equipment anomalies, and minimizes energy consumption. The refinery becomes both cleaner and smarter. Green hydrogen, electrification, digital optimization, and upgraded infrastructure work together to create a refinery with dramatically lower emissions. Existing facilities continue producing essential fuels while operating far more efficiently and sustainably than before. The result is cleaner gasoline, diesel, jet fuel, marine fuels, and petrochemical feedstocks. Consumers may never see the hidden hydrogen factory, but its transformation reduces the carbon footprint of products used by billions of people every day. Tomorrow's refinery will produce much more than transportation fuels. Green hydrogen supports sustainable aviation fuel, low-carbon marine fuels, ammonia, methanol, fertilizers, industrial chemicals, and future synthetic fuels. The refinery evolves into a diversified clean energy manufacturing platform. The refinery becomes a complete energy hub where renewable electricity, hydrogen production, carbon management, energy storage, digital control systems, and advanced manufacturing operate together as one integrated industrial ecosystem. By 2040, today's refinery could look remarkably different. Electrolyzers replace conventional hydrogen plants. AI continuously optimizes operations. Renewable electricity powers major systems. Hydrogen storage balances energy supply. Carbon emissions are dramatically reduced while industrial productivity remains high. No single technology will decarbonize oil refineries. Success depends on integrating green hydrogen, renewable electricity, carbon capture, hydrogen storage, electrification, waste heat recovery, and artificial intelligence into one intelligent engineering system. Together, these technologies redefine one of the world's largest industries. Most people will never see the hidden hydrogen factory inside an oil refinery, yet it may become one of the most important technologies driving industrial decarbonization. By transforming how hydrogen is produced, stored, and distributed, engineers are reshaping the future of fuel production and heavy industry. At ReneEnergy, we reveal the hidden engineering systems powering tomorrow's energy transition. If you'd like to explore hydrogen technologies, industrial schematics, and the engineering behind the world's largest energy systems, visit H2Hub by ReneEnergy. Because understanding the future begins by understanding the hidden systems that make it possible.